So you have a table, and notice that with logarithmic quite often, right, your x is one variable and the time is going on the y-axis. That threw quite a few of you off on the quiz. You put the time on the x-axis because you're like, no, time has to be on the x-axis. And logs is the one exception where time is quite often on the y-axis. So keep that in mind. Also notice how this is worded years since 1996. So technically this is 1997, right? So you just add, right? This is 1999. So you could have entered it like that if you prefer, to just have the years there, but most of you probably I chose to just enter these values, but you need to understand that it's years since 1996. So if you perform the regression, I really encourage you to tell yourself this and me that this is what you did, keystrokes, and there's your equation right there. It's natural log, not the ln. Okay, make sure you don't get that wrong. And so now I'm going to walk you through the graphs because there are certain things that I'm looking for. And so I'm going to try the Zoom 9. Let's see if it gets me started. It looks like a straight line, but we know that it's a logarithmic. So what I want you to start thinking of is, right, on your study sheet, you would tell yourself if this positive, right, in general, the graph looks like this. Okay? It never touches. You need to understand that that's what is that called? There's an asymptote there, right? It never touches, okay? And so we know that there's a 0.1 negative 557, which for us in this particular case will not be relevant, right? Because if this is time is only positive, right? So we start at the x-intercept and move forward. Okay, so let's go ahead and find that. So I already set my graph up. I'm going to come up with the x-intercept, right? y2 is equal to 0, second trace 5. And I need to adjust my window. I'm going to go -5 because x is my population. I'm going to go 60,000 there. My y min just below, y max I'm going for 50. And there's more to see, right? So there's your log graph, okay? If you find the x-intercept, that is 25,497.79. So what do you do with that, right? Well, it needs to show up on your graph. So you've got to come up with an appropriate scale to make that work. So I'm just going to use my ruler here, and I'm just going to try out, right? If I go up by 10,000, like 10 every second, right? 10, 20, 30, 40, 50, right? That'll do it. So the quiz, when you get it back, especially if you get a grid, I'm very particular with how many boxes are there in between your markings, right? So if I notice you have 2 boxes and all of a sudden you have 3, that's a 1 mark loss right there, okay? So I'm going to go 10,000, 20,000, 30,000, because it does say to include up to 50,000, right? So technically you could have gone a little bit bigger. I can still do that if I wanted to, but I'm going to focus on the 25,000. It's somewhere in here. So it should touch there, and I will come up with some reference points shortly. So if I go with 50,000, I want to make sure that if I include 50,000, that I also have an appropriate y value to make this fit, right? So before I come up with my scale, I'm going to focus on the 50,000. So I'm going to go second trace 1, right? X is equal to 50,000. Let's see if I manage to get that. There we go. Y is equal to 36.98. So if I go up to 40 here or 50, that'll do the trick. Okay. I'm going to go 1, 2, 3, 4, 5. Right? right? So I'm going to go up by 10. There we go. On the test, most likely you'll have a grid, most likely, but still be consistent, right? So I'm going to make this my reference point. 50,000 gets me to 36. Can I just match that as best as I can? Right about there. And so that's my reference point, so I know it's going to go like this, right? And you can just make the arrowhead go like that, and the equation, because most likely it's not going to be there, right? And so if you have the scales, that's 1 mark. If you have all the labels, right, that'd be another mark. And then the correct shape of the graph, including the x-intercept and that reference point, would be another mark. So 1 mark for the shape, 1 mark for the labels, and 1 mark for the scale. That's usually what I look at. Scale, labels, shape. Yeah. I told you have 3, right? Something like that. So I would say more is better. So this is what I sometimes look at. Like, I kind of know on my graph where this point is supposed to be. If you somehow give me like a weird like this, right? Like something that's not, then you might lose some marks. So I would maybe say, hey, let's find one more. How about 40,000, right? That's a good point. That's a good point. So I'm going to go and just check. That's 2473. So I kind of match that. It's a little high, but you wouldn't lose marks necessarily. So maybe throw in a third one in there to be safe. Yeah. Are you supposed to put the arrow? That's also a good question. I didn't take any marks off for you missing that. Because with these, because they do go to infinity, right? There's no stop to population growth necessarily, right? In reality, like it's going to keep growing even a little bit. It will plateau. So keep putting the arrowheads on there. If I tell you 50,000, it's just like make sure you include up to 50,000 or something like that. It's okay to put the arrowhead on there because we can't say at 50,000 unless it does specifically say, like the petri dish. I'm thinking of that question. It says it can only grow up to this much, and then there's not enough food for it to continue growing. If there's an absolute cutoff, then stop it. But if it just says graph something including up to 50,000, a population of 50,000, then feel free to include that arrowhead there. So just watch for the wording. If you didn't put an arrowhead today, we'll let it go, right? Because it's a little bit, sometimes it does stop, sometimes it doesn't. So what's going on here? If this is your problem right now, that's the least of my concerns. I want everything else to be there. All right? Okay, moving on. According to this equation, in what year will the population reach 40,000? Population is X, right? Second trace. If you can tell yourself that, what is X, what is Y, right? Somewhere at the top, tell yourself. Then this will be a breeze, right? And that actually, this you should be able to put on your graph, right? 2473. So when you have that, sorry, this should be Y, right? Y is equal to 24.73, and don't just leave it there. What is that, right? So we're not quite done yet. This would be how long it would take, but it does ask in what year. In the year, we will go 1996 plus 24.73, and that's 2020.73. So approximately 2020 or 2021. I would accept either one. As long as you round to a whole number, because it is in what year. It doesn't ask how long. Okay. So I'm going to make this one. How many marks is this? I would make this worth 2 marks. So if you get the 2473, you get a mark. And if you actually went further and came up with the year, you get another mark. Okay? You entered the years into your Y2, L2, I mean? You got straight, you got 20. Perfect. Yeah, because you did this work earlier. Yeah, absolutely. Yeah, you still get the 2 marks. D, according to this equation, how many people will be living in Nunavut in 2017? So you need to first figure out, except for Raghav, you don't need to figure this out because you did the work ahead of time, right? You subtract 1996 from there and you get 21 years. So you would go Y2 is equal to 21, and then second trace 5. X is equal to 37,374.27, which is approximately 37,374 people. Okay. I would give you 1 mark for figuring out the 21 years, and then another mark for coming up with the total there. The graph was worth 3 marks, and the equation was worth 1 mark. So we are at 1 and 3 is 4, 5, 6, 7, 8. This page is worth 8 marks as is. And I was happy. I asked you how long would it take to grow from here to here on the quiz. I would say most, if not all of you, did it the right way. Your answer might not be the same as mine because you made a mistake upstream. But this page is worth 8 because that's where it stops technically, right? Now we're going to do the bone. We're going to figure out bonus. Ooh, time is flying. Okay, I take my time because this is the only 2 examples of log regressions, and I just remembered something. You had a whack load of points to go off of. Did you notice that? These are all points you could have used to graph as well. However, I kind of stick to one method because the equation is the most common, right? You always come up with an equation or you're given an equation, so then it's kind of like that's how you roll, right? But anyhow, there it is. It is acceptable if you have a grid and you put every single point on there, a scatter plot, and then you connect those points, it's acceptable. I would give you full marks for that. Okay, so the back is bonus. 5 Americans, 6 Canadians, 11, right? I'm just going to make a note that that's 11. A group of 5 is being selected to represent North America in the upcoming UN conference. So a group of 5, you should think combinations, right? There's no specific job. So I'm hoping that you remember that. It's like a lifetime ago almost, right? How many groups of 5 can be created? I'm glad you asked, right? I will give you the answer. 11C5, and that's 462 groups. Okay, that's 1 mark. That's 1 mark. How many groups without Americans? How many groups without Americans? Well, you need to kind of think of this. 5 Americans choose 0, and from the 6 Canadians, we're going to choose 5, correct? 5 choose 0 is just 1. So even if you missed it, you're still going to get the right answer. And that's 6 groups. I don't have the individual. Well, this I know is 1. And this must be 6, right? Because it's 6. See? It's not bad. I still function every once in a while. So that's 1. What's the probability of having no Americans on the team? Right? Well, that would be 6 over 462. 6 over 462. If you reduced it, that's 3 over 231. If you came up with a decimal, it's 0.0130. But 4 over 462 does the trick. Yeah, it does the trick. What's the probability of having at least one American on the team? You have everything you need right now. You don't even need to do anything else. So probability of no Americans, you take, obviously it's still out of 462 are all possible groups. Then you'll take the 462 and subtract. What are you going to subtract? 6, right? Because this is all the groups that would not have any Americans on it. And that is 456 over 462. If you can't stand not reducing, then that's what you would get. If you don't like fractions, because you're traumatized, then that is it. And then if you want percentages, then that is it, right? All right. How many ways can all representatives be arranged if the Canadians are grouped together? Arranged, right? So it's like a grouping involving permutations, though. I don't know if you have that formula on your study sheet. Do you? Do you not? I don't know. Maybe you remember. But it goes like this. The group of all Canadians would be 6. You factorial that one. And then you take all of them and you start subtracting, right? How many members are in that group. And then you need to go plus 1 factorial. So 6 factorial times 6 factorial. And that is 518,400 ways. And some of you are like, what is he talking about? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There. Right? So 1, 2, 3, 4, 5, 6 Canadians. These are all supposed to stay together. Right? So that's why we go with the 6 factorial. And then this group can be moved around, and you can put the Americans around this group. So you have 1, 2, 3, 4, 5, 6 on the outside. That's why it's 6 times 6 factorial. This is just a formula to help you out. Okay. F. Probability of having all Canadians grouped together. All Canadians grouped together. Well, we just recognize that all Canadians grouped together is this, right? And what would go down here? 11 factorial, right? It's just all of them, right? 11, 10, 9, and so forth. It's just all of them, no restrictions. So that would be 518,400 over 3,991,6,800. What is that? 39,916,800. And you can cut the trailing zeros and do all kinds of fancy stuff. But if you have that in my books, you know what you're doing. You're doing good. Percentage-wise, I think it's 0.0130. Interesting. And yeah, 1.3%, 1.30%. So I would say you get a bonus mark for every one you got right. So just add, if you got them all right, then it's plus 6. If you got one of them right, plus 1, right? So just add to the total in the front, whatever you got there, just add the bonuses. And yeah, a lot of you are going to be over 100%. It's going to make up for some of these maybe you didn't do so well on. That's on the house.